Hey everyone, Savage Sullivan Math here. Welcome back. Happy to have you. Today we are solving polynomials. What does that mean? Well, it means that we can find the values for x that make this equation work, and we call those values roots. So the thing you need to do first is you need to look at the problem and you need to say, the easiest way that I can find the roots is if I can use the zero product property, which means I have to make sure that I have this equation set equal to 0. This one is not. This one says equal to -9. So that's an easy fix for us. We are going to simply add 9 to both sides of the equation. Remember, whatever you do on one side, you have to do to the other. That means on the right-hand side, we're going to have equal to 0, which is what we want. On the left-hand side, we have to think about that 9. Can it combine with either of these terms that are already there? No, sure can't. They're not like terms. So that's just going to come down as a third term. So we have a polynomial now on our hands. So we are looking at 5x squared minus 18x plus 9 is equal to 0. So we need to factor this. Okay, we can factor this. We just need to first look for, that's right, a GCF. I don't see a GCF here. So the next thing we need to do is look for our magic numbers. Remember, we are looking for two numbers that are going to factor down so that they will multiply to a 45, because 5 times 9 is 45, and they will add to a -18, our b value. So again, we get that multiplying by taking a times c and our adding number from our b value. Okay, well, if it's going to multiply to a positive number, I know that my two numbers have to either both be positive or both be negative. I can narrow that down further because I know that it needs to add to a negative number, which means I am looking for two negative numbers. All right, here we go. -1 and -45. That does not add to -18, so that is not our number. 2 doesn't go into 45, but I know that 3 does. 3 goes into 45 15 times. Hey, guess what? We found it. Here is our magic numbers. Since our a value is not 1, we're going to use our magic numbers to replace our middle term. So remember that first term stays the same, and instead of writing -18x, we're going to write a -3x and a -15x, and then don't forget about your positive 9 is equal to 0. I'm going to take some time now, since I have a polynomial, and I'm going to group these so that I can factor it completely. Remember, these grouping parentheses are not signifying multiplication at this point. I'm just grouping these together for my own visualization of what I'm going to pull my GCF out of. Okay, so in this first parentheses, the GCF of the parentheses would just be an x. Left behind would be 5x minus 3. Okay, I want my parentheses to match here. Okay, so what would I need to take out of a -15x to leave a 5x behind? That's right, it would be a -3. So if I take a -3 out of -15, left behind would be a 5, and don't forget your x. And if I take a -3 out of a positive 9, left behind would be a -3. Don't forget, still equal to 0. Perfect. Our parentheses match right here. So we are able to write our final factored form, which would be the matching parentheses and then everything that was outside. And it's still equal to 0. Now, if you want to redo the double distribution and make sure that you come up with your original problem, that would be fine. So at this point, we're almost done. We just need to figure out what the roots would be. So we're going to take this 5x minus 3, and it's going to be equal to 0. Because remember, we're using the zero product property, which means if one of these terms is 0 and you multiply it, then the answer has to be 0. So either 5x minus 3 is 0 or x minus 3 is 0. And we just solve. So we're going to add 3 to both sides. And we get 5x is equal to 3. Divide both sides by 5. So x is 3/5. Or we're just going to add 3 to both sides here. So x is 3. So the roots are either 3/5 or 3.
Epic job, Mrs. Sullivan. Let's find the roots of this one. So, like always, when we start these problems, we always want to start by factoring by a greatest common factor if we can. So when I look at this polynomial, what's standing out to me right away is the fact that there is a greatest common factor this time. So when I look at 18, 15, and negative 12, the greatest common factor between those three numbers is 3. When I look at each of those terms, I also realize that they each have an x. So I can pull out 3x as my greatest common factor. When I factor out 3x, I'm left with 6x squared plus 5x minus 4. Okay, those are nicer numbers to work with than the top. So I'm going to go ahead and now kind of focus in on this inside trinomial, and I'm going to factor it exactly like Mrs. Sullivan did. So multiplying our a times our c, 6 times negative 4 is a negative 24. So we are looking for numbers that multiply to negative 24 but add to positive 5. Can you think of those factors? Yep, that would be a positive 8 times a negative 3. That would multiply to a negative 24 and add to a positive 5. So when I go to rewrite this now, I'm going to have 3x, remembering that my greatest common factor has to follow me all the way down, and then 6x squared, and we're going to rewrite that 5x with the factors, so that would be plus 8x minus 3x minus 4. Okay, now we're going to group our terms. So when I look at this, what I'm going to do is I'm going to group the first two terms together, and then I'm going to group the last two terms together. So again, our GCF of 3x is going to just come down. And now I'm going to use a bracket, since I already used a parenthesis. And what's the greatest common factor of 6x squared plus 8x? Well, that would be 2x. Once I pull out a 2x, I'm left with 3x plus 4. Again, I could check that by multiplying it out and make sure I get here. Now, if I want my other set of parentheses to match a 3x plus 4, we're pretty close here, but this is a negative 3x and this is a negative 4. That must mean that I have to pull out a negative 1. When I pull out a negative 1, that would cause my parenthesis to become 3x plus 4. Again, checking if I want by multiplying that through. Now my parentheses are the same, which is always what we want when we factor by grouping. So now we're going to rewrite this entire polynomial. So again, making sure that I don't lose that GCF of 3x, that's going to come down. And we have our parentheses that are the same, so those get written 3x plus 4. And then the leftover terms, 2x minus 1. And not forgetting to set it equal to 0. Whew, all right, it's factored. Now we can go ahead and find our roots. So using the zero product property, saying this times this times this is 0, we're going to set each of these terms equal to 0, or I should say each of these expressions, or each piece of this polynomial. So we have 3x equals 0, we have 3x plus 4 equals 0, and we have 2x minus 1 equals 0. Now, it's just simple solving equations. So here, we know that x is going to be 0. Here, when we solve this, we subtract 4. We end up with 3x equals negative 4. Divide both sides by 3, and we get x equals negative 4/3. Totally okay if we get fractions. And finally, add 1 to both sides. 2x equals 1. Divide both sides by 2, and we get x equals 1/2. So in this scenario, we have 3 roots. X is 0, negative 4/3, or 1/2. Nice. Lot of work, but not super complicated if we know how to factor. If you found this video helpful, please like and subscribe.